So we're going to set up our Docker container. First, we need to download Docker. If you go to docker.com, you should be able to download it right from their homepage. I've already got it installed, as you can see here. If I go to dashboard, we currently have no containers. So let's set up a container. Within our code, what we want to do is we want to make a file to allow Docker to understand what node version we want, where we're going to install it, what we're going to install, and then how to build the TypeScript. So what we want to do is we want to add a new file and call it Docker file. This has got a capital D. Then we want to say from node 18. As you can see down here, I'm using node version 18 locally, so I'm going to make sure that my Docker use is the same, just to avoid any complications with version mismatching between local and my container. Then I'm going to give it a label. So I'm going to type in label, name, and I'm going to give it the name of nodeJS API, like so. Once I've done this, you can set the working directory. You do that by typing work dir, and then you can choose the working directory that you want your app to be installed into. So I'm going to do user source app, like so. Once we have this, because we already have node available to us with the node being pulled here, we're going to then run npm install -g to install globally across the container pnpm, because we want access to pnpm so that we can run all of our commands like we do locally. Once we've done this, we need to copy all the files that we need. So we're going to copy the package.json, but we're also going to copy the pnpm lock file, like so. The reason why we use the lock file is because once we've installed a package or a module, we don't need to re-download it unless the version's changed. So this just basically keeps track of the last version that we installed so that we don't have to re-download it every time. Once we've copied this, we're then going to run the pnpm install, like so. Now we want to copy the TypeScript config, and we also want to copy the source directory, like so. Once we've done this, we have everything we need for Dockerfile to run the build, so we're just going to run the build. Cool, so now we've set up the Docker container. We want to set up a Docker compose so that we can easily compose other services, be it a Postgres service, a Mongo service, a Redis service. We can have it all running in the compose file so that when we run Docker compose up, it builds everything and it runs it all in parallel. So to do this, we're going to add a Docker compose file. So we're just going to type in docker compose.yaml, like so. So now that we have our Docker compose file, we want to set up a service for our API. Before we do so, we just want to define the version that we're using. So I'll be using 3.8. If you head over to the Docker compose docs, you can see a list of all of the versions supported. As you can see, 3.8 is the latest one to date. Once we've done this, we're going to set up our first service. So within the services, we're going to make a service called API. Then we're going to tell it to build within the current working directory. We're going to say what ports it's going to be using. We want to be using ports 2000. Then we're going to expose these ports so that we can access it from our local machine. Once we've done this, we're then going to set a restart property, and we don't want it to restart unless it's stopped. The reason why I do this is because if there's an error, I like to check the logs and find the error. If it automatically restarts whenever it crashes, then it could be a pain in the ass to scroll back and try and find the error. So I just do this here. We're only going to be using Docker Compose locally, as when we host this, we're going to be building from the Docker file, so we don't need to worry about any of this stuff on a production environment. Once we've done this, we're just going to define the volume that it uses, and just like what we used in our Docker file, we're going to make sure we use the same working directory as we use there, like so. Now that we have this set up, we're going to give it a command. Now the command that I want it to run is pnpm dev, because we want to run the development environment, because again, as we're going to be using this locally for development. Then we're going to set up an env file. Now the file that we want to use, you could do .env, but I like to do .env.development, because you may have a .env.production, an env.test, and you might want different env files depending on where you're running your application. So now that we've done this, we have our first service set up. So how do we build this? Well, we can go down to the terminal and we can just type in docker compose build. Now, as you can see here, we have node.env.development. So let's create that. So in the root of our directory, we're just going to make a new file called .env.development. Now, once we have this, we can run docker compose build and it will build. Now, this may take a little while for you because it needs to download the node version, it needs to download everything for your Docker container. But once it's done that, and it will install pnpm and copy all of the files just like we set up in our Docker file here. So now that it's done, how do we run it? Well, we just type in docker compose up. Now this will bring the container up. And as you can see in our Docker dashboard, it's now up and running. So it says server is listening on port 3000. So let's go to server port 3000. You can see that the server can't be reached. And this is because we're trying to access it on port 2000, although we've hard coded it that it should be running on port 3000 in the code. So this is where environment files come in. So what I want to do here is I want to set up a couple environment variables. One, it's going to be node env, and we're just going to set it to equal to development. This is in case we want to access or find out where we're running this file from, whether it's production, staging, local development. We can change this here depending on the environment we're in, so that in the code we can make changes depending on that environment. The next thing we want to do is add a port, and this will be 2000. So once we have this, we then want to use this port in our code. So how do we use environment variables? Well, it's simple. We just write process.env and then the environment variable name. So we can do port. Now let's change this server log here, and we can just say server is listening on port and pass in this process.env.port. And then let's say in process.env.node.m, like so. So a restart, but you'll see that it says server is listening on port undefined in undefined. Now to pull in these new environment variables whenever you change them, we want to restart the server. For this, we can just Control C and then docker compose up again. Now you can see that it's running in port 2000 and running in development. So if we go back here and refresh, you can see that now if we go to port 2000, we'll have our application. And everything works exactly the same, so that if we change this to, I don't know, restart, it will automatically restart when listening to changes, and once we refresh, the changes will be applied. So now that we have our Docker container set up, let's go over neatening up some of the files and making some routes and making it a little bit nicer within our server. Okay, so the first thing I like to do to neaten things up a little bit is just to make a bunch of folders. So the folders that I like to use, and really this is your choice, but if you're following along, then feel free to copy me. So I have a roots folder. I also like to have a store folder. Now the store folder is what I use to interact with any databases, and this is because if I, for example, if I start using MongoDB, and then later down the line I want to change to Postgres, instead of having to go through all of the files that I made and change everywhere that I've connected to the database and done a query and fetch data, all I have to do is I just have to change the functions within the store, and then all of my files can use the functions in the store, and I'll have unit tests around that so that it makes sure that I collect and pull the correct data, and as long as I change that stuff, then I know that everything else will be fine. So that's what I use the store for. Then I like to have a libs folder. So this is any libraries like MongoDB or Mongoose for connecting to Mongo, and various other libraries that I may use throughout the server. And then I like to have a common folder. So this is just like common functionality, which hard to say off the top of my head what it might be, but anything that I would be using across multiple routes or anything like that. So once I have these folders, now I'm going to create some routes in the routes folder. So what I want to do is I want to create a user.ts and an auth.ts. So you can see in user.ts, I've got like this boilerplate here. So we import router from Express, we then make a router instance, and then we do router.get, pass the request and the response, and we just respond with the user root. So here we could do like router.post and then do so on and so on. We can also, instead of passing in the function inline here, we can also just link directly to a controller, which we may do in maybe the next tutorial, probably when we get closer to defining the user roots. Also, to make this appear more like an API, let's just do user.json, and then let's just do like a user name, like so, just so that it returns something that looks familiar to an API. And then we're just going to copy and paste this into the auth, and then change this. Well, we'll keep that for now, just so that we can, or in fact, just because we want to differentiate between the roots, we'll just change it to this. So now, how do we use these roots in our index? So what we can do is we can import our roots up here. So if we import user roots from roots user, and then do the same with the import auth roots from roots auth, instead of listing them all out like this, we can just do app.use, and then we can basically use the base URL. So we can do /API, and then if you're versioning your API, which I recommend, you can do /v1, and then user, that would point all towards the user roots, like so. And then we can just do the same for the auth roots. Like so. And I like to add semicolons, although they're optional here. So yeah, completely up to you whether you add those on. Okay, so now if we look into this roots file and we go into the user, you can see that it's a get /. So this / is right on the base of this initial URL. So if we go to Chrome now and we go to /API /v1 /user, you can see that we now have the user name is John Doe, and then if we do the auth root, we can have auth true. So this is now working as expected. The next thing I like to do to clean things up a little bit is to make a config file. So this config file is what I'm going to use to store all of the environment variables that we set up. So what I can do is export default, and then we're just going to export an object, and for example I could do port, and this is where I can just map it to a number and do process.env.port, and then I can do environment and do the same thing for the node environment. That means instead of having to write out this everywhere, I can just type in the config, which I will import .port, and then let's import that config up here. So import config from config, and then we can do this, we can do config.env, and change this again to config.port. Now, if I wanted to change that environment variable to something else, or to be named something else, the only way that I would have to change that across all of our files would be really annoying. So now I can just change it in this one file, and then because we use this config file, we can just change it here and it just updates everywhere, and we don't have to worry about that too much. We also get typing on this now, so if we type in P we get port, or env we get env, so that's also helpful. Another thing I like to do in my projects is use prettier and ESLint, just to make sure that the coding conventions that I'm using are remaining the same across all of the files. So you can see here we've got semicolon, no semicolon. Now, although semicolons are optional, I do like to maintain whichever coding style I choose across all of the files. So what we're going to do is we're going to install, well, first we're going to cancel the Docker, like so. And then if we want to make sure the Docker Compose is down, we can just write in Docker Compose down, like so, and it will just remove the container. Okay, so now we're going to clear this out, and we're going to do pnpm i-d to save in the dev dependency, and we're going to install the prettier. Okay, so now that we have this, we're just going to make a prettier rc.json file. And now this is where the config of the prettier is going to go. So this is where you set all of your rules. So the first one you want to add is trailing comma, and we set this to ES5, choose the tab width, choose whether you want semicolons or not. I do, call me old school, but I like it. And then lastly, we can choose if we have single quotes, true or false. I like to use single quotes, so I'll set that to true. Make sure we wrap this in double quotes because it is a JSON file. Okay, so now that we have that, you can see that if we go back to the index and now we press Command S to save, it's going to automatically format this for us. So this is working perfectly, but sometimes your code editor may not format this for you. Z does and VS Code does. It's all in the config of the editor itself, but we can also add a format option onto our scripts. So we can go and add a format, and we can do prettier -- format, I believe, or it might be check. And then we just include the source file. So we can run this, and then we can do pnpm format, and it will check, and coding style issue found in the above. So in source.config.ts, it's been found. Okay, so let's go into that. And then if we click Command S, you can see that it adds in these semicolons. And now if we run it again, there you go. All coding format has now matched our coding style. So perfect. Next thing we're going to do is we're going to add ESLint. So we're going to do pnpm, in fact, yeah, pnpm i-d ESLint, like so. And then we also want to add the ESLint config prettier extension so that we can basically allow the ESLint to run off the prettier rules that we just set. So we're going to install those. Now, once those installed, what we're going to do is we're going to run npm init and then ESLint -config. Now this is going to basically ask us a bunch of questions on how we want to set up the ESLint. So I would want to check the syntax and find problems. JavaScript modules, none of these. We are using TypeScript. We're running it Node. What format do you want the config to be? I like mine to be in JSON. And then, would you like to install these plugins? We do, because we want to install the TypeScript parser. And yep, awesome. And then, which manager do you use? We use pnpm. Okay, so now these are going to install for us and set up an ESLint config file. Okay, so now that these are installed, you can see that we have the ESLint-rc.json file here. And we're going to keep everything the same. We're going to add in our prettier extension to make sure it reads off of that config file. And we're also going to add in and ignores. So ignore pattern like so. And then we're going to add in node modules and dist, because we don't want ESLint to check for errors in our compiled JavaScript. We only really care about it in the TS files. Okay, so now that we have that, we're going to add a new script to our package.json called lint. And then this is just going to run ESLint check within the source folder, like so. So now if we do pnpm lint, it's going to check. Invalid options, check. Okay, I just don't think you need this. I think it's just ESLint source. Like so. Okay, so no errors returned back. So, but if we go back and we say we've missed off the double quotation here, and like TypeScript errors for us anyway, but just so we can double catch it, we can run this and it'll be like, oh, there is a problem. So we can go in and we can fix that, and there we go. You can also add this as a hook onto pre-committing to GitHub to make sure that everything is linted correctly and formatted correctly on every commit. I don't choose to do this just because I have it auto-saving, auto-formatting on saving, but you can go ahead and look up how to do that. It's fairly straightforward. The next thing we're going to go over is adding clusters to the server. Okay, so the first thing you want to do when adding clusters is first you need to import cluster from cluster. Now this package is already installed with Node, so you don't have to worry about installing that. And we also want to import OS from OS, and this is so we can read the number of CPUs that we have available to us. The next thing we're going to do is here, we're going to do if cluster.is primary, this is if it's the primary node. We're going to first get the count of the CPUs available to us. So we're going to do const CPU count is equal to the os.cpus, which is a function, and then we're going to get the length of that. We're then going to do a for loop, iterating the I variable over to the CPU count, and then for each CPU we're going to fork the cluster. Then within the else condition, we're going to wrap all of this in the else so that this gets printed out for every one of our clusters. Okie dokie. So now what we're going to do is we're going to do docker compose build. The reason I did this is because I did docker compose down and we've installed some packages since I last ran it, so I just want to make sure that those packages are installed. This should be a lot faster than previously. So you can see that this is now being built. I'm now going to do docker compose up, and what you'll notice is that once it starts running, it's going to print out this log multiple times. So you can see here, server is listening, server is listening, server is listening. Now, how we want to differentiate between these is we can just add a server, and then in bracket we can do process.pid, like so. And then if we save this, you'll notice that each one of these will have a different PID, so you can tell the difference between each instance of the cluster. Okie dokie. So what I normally do is, because I don't need 5 instances running when I'm in development mode, I normally like to do a check. So I'll normally change this to like a let, and then I'll do an if a config.env is equal to development. I can just set the CPU count to 1, so only 1 will run in development mode. So if we save this, you'll notice that only 1 will run. And then rather than writing out a string of development here, what we can do is we can, in our config, we can add a export type, and we can do environment, and then, in fact, let's make this an enum. You shouldn't use enum for some things, but I think this would be one of the reasons why you can use it. So we'll set up a development, production, and also a test and a staging. I thought it was going to auto do that from Copilot, but it didn't. So staging, like so. And this is just so that we can then go into the index, we can import that environment, like so, and we can say if the env is equal to environment.development. And I just find this a lot easier to read and make sure that I only have to check the spelling in one place. Yeah. Okay, so yep, now that's all done. We've got clusters set up. That's pretty much it for this lesson. So to conclude, we set up a Docker container, then we went over and we cleaned up all of our files and set up all of our routes. We added ESLint and Prettier to make sure that our code signing remains the same across our code base. And then we added in clusters to the project to make sure that we're utilizing all of the CPUs, because nodeJS is a single-threaded language. In the next lesson, we'll be going over adding in a couple more services to our Docker Compose, and those are going to be the database, which will most likely use Postgres, and we're also going to add a Redis. We'll use Redis for a pub sub for when we want to add WebSockets to our application. WebSockets will be good for if we want to do anything in real time. We're also going to be going over adding in some unit tests to make sure that all of our application functions are working as expected, and we can test each part of the function so that we're confident when we're pushing this up to production. We'll then go over hosting this, where I'm going to host this, and setting up some private gateways and networks to connect to an online Redis and online Postgres database. I'll see you in the next lesson. Don't forget to subscribe, like this video, and join my Discord server if you want to chat about anything, if you have any issues with the lesson, or if you want to suggest something for the next lesson or future tutorials. So yeah, thank you.